Hello everyone. In this video we will see how do we evaluate double integrals with variable limits. It means one of the limit will be in terms of a variable. Like you can see this example, the limits are from 0 to pi by 2 and 0 to y. This is a variable instead of constant, which we saw in 3.1 in the previous video. Okay, so let's see how do we work in this case. Actually, the process of solving this question is similar. Just the only thing is you have to substitute the limits in terms of variable instead of numbers. Okay. So as you are starting like integral with dx and dy, so it means these are the limits for x and these are limits for y. We begin by solving this integral first. Okay. So let's write this. So we are solving this integral. Okay. So the first thing, as usual, what we have to do, we have to check like we are integrating with which variable. So dx shows us we have to integrate with respect to x and the constant will be the other variable which is y. So you see that in this entire term, it is sine y over y. We don't have x, right? No x term. So what will be the integral? Integral will be, is this all is a constant, sine of y over y. And since there is no x, what we will do? We will write here x. And the limits are from 0 to y. These are the limits for which variable? X. How do you know that? Because you are integrating with respect to x. So x is from 0 to x is equal to 1. So what you have to do next is replace this x one time with y and then by 0. So this gives you sine of y over y and then y minus 0. This gives you sine of y over y times y. So we can cancel this y and y together, which gives us the value as sine of 1. So see, it is similar to what we did with the constant limits. Okay, exactly the same thing. So now we will use this value. Let's say this is I, this is the first integral, and this is the value of this integral. We substitute it over here. So this gives us now outer integral 0 to pi by 2. The value of I is sine of y dy. Now it's a function of y only, there is no x. So it means we did it correct. Or you can write it as, instead of writing no x, you can say only y. Means you should see only one variable. Okay. So now integration of sine of y is minus cosine of y. And the limits for y is from 0 to y by 2, which gives you minus cosine y by 2 minus cosine of 0. What we did here, we substituted the limit. This is the term when y is pi by 2 and this is when y is 0. After that, you just need to substitute the value. Okay, cos of 90 will be 0 and this become plus cosine of 0 is 1. So the value of integral is 1. So this is how we evaluate a double integral with variable limits. Now let's take another example so that the question will be clear. Now you have integral 0 to 1, 0 to e power x, x dy dx. Don't get panic when you see the integral limit as e power x. Just relax and do it in the same way as we did previous question. So what we are going to do, we will be solving this integral. Okay, write it down. Integral 0 to e power x, x dy. Okay, so we are integrating with respect to which variable? y because of dy. And constant is x. Now, as we are integrating with respect to y, it means these are the limits for y. Okay, so y varies from 0 to e power x. Now, what term we have here to integrate? X. Integrating with respect to y, it means no y. So, what will be the integral? X constant remains same. There is no y, so you multiply with y. Okay, and the limits for y from 0 to e power x. So this gives you x e power x minus x times 0. What we did? We replaced this y by e power x and then by 0. So this gives us x e power x. So this is the value of our integral that is in this box. Okay, now returning back to our original question. We left with this integral 0 to 1. In place of this, we can write x e power x dx. So see here, we finished integration with respect to y. So we left with only x term. Means only one variable. Y variable gone. So it means we did correct. Now it's a simple definite integral that you have to integrate. You see the product of two terms. You cannot merge them together to make one. So as you have already familiar with this, so one of the function is algebraic, another function is exponential. You have to solve it integration by parts. Okay. So in this case, you can use any method. You can use the method, say, integral of u dv, which is uv minus integral v du, or you can use Bernoulli method. Okay. I'm going to solve this by using Bernoulli method. So I will select one function for differentiation, another function for integration. Why this is possible? Because one of the function is algebraic. Means you have a function which after certain derivatives becomes 0. So you select x for differentiation and e power x for integration. So derivative of x is 1, further derivative is 0. So we have to differentiate 2 times to reach 0. So we will integrate 2 times to reach to this label. Then we just have to write down the term starting with plus, minus plus and multiplying and cross. Okay. So this gives us the value of this integral as x multiply e power x minus 1 multiply e power x. The limits are from 0 to 1. Since it's only one variable, it means these are the limits for x. Substituting the value of x at these three places, 1 and 0, what we will get? 1 e power 1 minus e power 1 minus 0 e power 0 minus e power 0. So these are the limits at x equal to 1 and this at x equal to 0. So these two terms are same, cancels to 0. 0 multiply anything becomes 0 and only e power 0 becomes 1. So what we get? 0 minus 0 minus 1. So gives us the value 1. So the value of this integral is